There you go.
All right. Well, nope, not good morning. Good afternoon, everyone. Welcome to the Colorado LTAP Wednesday workshops. We present these in our off seasons, just to provide information on the latest and greatest in the transportation industry, new innovations, all of those cool things. We don't have a ton of people on today, but just housekeeping stuff, normal meeting rules apply. Keep your microphone muted if you're not talking right now. As usual, these are going to be uploaded to our YouTube channel so that we can view them on demand at any time. Just one quick disclosure, Colorado LTAP does not endorse products, manufacturers, or outside entities. This presentation is for informational purposes only and is not intended to reflect approval or endorsement of any one product or entity by Colorado LTAP. So with all that gotten out of the way, I will toss it over to our presenter today. This is Todd Gonser with Cutler Repaving.
Let's see. Thanks, Katie. I'm going to try sharing my screen here without. Let's see. How's that look?
Still loading on my end, so just give it one second.
Gotcha.
There we go. Perfect.
All right. So Zach got that title screen up there, I guess.
Yep.
There we go. How's that?
Awesome. Looks good.
Perfect. Sorry about that. I'm not technically as adept as Katrina is, but thanks for having me. It's a pleasure to be here, speak on our Colorado LTAP Wednesday workshop series. So my name is Todd Gonser. I work for Cutler Repaving. For 13 years, I was a pavement materials engineer for CDOT up here in Region 4. And this will be my 13th year with Cutler Repaving. So on the dark side of things, but just thought I would explain a little bit about our process. It's called heated repaving. It's a method of rehabilitating asphalt pavements out in your inventory. So we'll get started here. I'll just roll through a PowerPoint presentation that we've put together. So some of the hot topics, I'll give you an overview of the HIR process, talk about some local agency stuff and lessons learned, and then time at the end for questions and answers. So I'm not sure if anybody is live in the chat room, but if you got a question, go ahead and type that in, and we'll get to it at some point along the presentation today. So pavement preservation economics, this is usually what every pavement manager, local agency will come down to in their system is how can I do more with less money or even do more with the same amount of money. So as we all know, funding is getting a lot tighter and our pavement system across the board is getting in worse and worse shape. So the basics of pavement preservation economics, how can I maximize return on that investment? Basically get the most bang for your buck. So this is a pretty common theme across the industry. If you can repair your asphalt pavements during the first 40% drop in quality, you're doing well. So I guess the old way of thinking, and I say old because I was involved in this process not too long ago, we repair worst first conditions in our pavement system. So if there's a asphalt pavement that's totally fallen apart, we put all our money and all our effort into fixing that. Well, that's kind of like I said, the old way of thinking. That's gone by the wayside. It's totally inefficient, and pretty much every local agency, DOT, anybody that's in charge of fixing roads has gone away from that system. It's very cost ineffective to totally rehabilitate your worst roads or your worst streets in your system. A better way to do that is to do pavement preservation treatment. So here's a graph that's pretty common. Your pavement condition when it's brand new is 100%, right? And as it goes along, it totally starts falling off this curve to where it's total failure. For asphalts, it's usually about 12 to 15 years is when it's gone to total failure. So when it needs a total reconstruction. But in that first 75% of the time, or somewhere out in the 6, 7, 8 year range, that curve isn't as sharp. So if you can do something in that first 75% of that lifespan, you can really make a better cost-effective treatment to your road. So over those first few years, the pavement condition doesn't drop off quite as steeply. So the first 40% drop in quality, to fix that, let's just compare apples to apples here. Those type of treatments would cost you $1. Where if you were to wait for the next 40% drop in quality out towards the steep part of this curve, 8, 9, 10, 11, 12 years, to fix something that's that far gone would cost about 4 to 5 times as much. So that's just the basics of pavement preservation economics. If you can keep a good road good, it costs you less and in the short term, and it costs you less in the long term, because the theory is you're going to save enough money by keeping your good roads good that you can have extra funding after 8, 9, 10 years that you can go back and really sink a lot of your big dollars into fixing your roads that are way far gone. So keeping good roads good is the catchphrase, and that's kind of what this graph illustrates. The other thing we're thinking about is the right treatment on the right road at the right time. So you want to maximize, again, your bang for the buck, but you want to do a treatment that's the right thing to do on the right road at the right time. That's the key. So we're trying to find a niche in that pavement deterioration curve where you're doing a mid-level treatment at the right time to maximize the funding that you're sinking into it at that point in time. Which leads me into what I do. This is just an example of a type of pavement preservation treatment. Some of you may have seen this. We do a lot of local agency work here in Colorado, a lot of DOT work for Colorado, Utah, Arizona. But it's what's known as hot in place recycling. And more specifically, Cutler Repaving, the company I work for, is called heater repaving. And we'll get into the specifics of that here in a little bit. But if you're out there looking at your road system, this is a good example of something that might need a minor treatment. So in other words, a chip seal or a slurry seal, it's a little bit of oxidation, got a crack here or there. And it's pretty high up on that deterioration curve. This is just another slide of that very same thing. So in the first 3, 4, 5 years, you might do something that's a minor treatment, chip seal, microsurface, slurry seal. Here's an example of the other end of the spectrum. This is a road that's pretty far gone. You can see it's got a lot of issues. It's had probably years and years of patching. It's really fatigued, cracking over there by the curb and gutter. It's totally raveled out and totally gone. Got some pretty big rutting going on. So this guy would need a major treatment, which is your mill and overlay, or total reconstruct, building from the bottom up. So as you get out there 10, 11, 12 years to where that curve has dropped off pretty steeply, that's where you have a major treatment. So these pavement preservation treatments I'm going to talk about, hot in place recycling, specifically heater repaving, those are more of a mid-range treatment. So here's a road that might have some utility cuts. It's got a little bit of fatigue cracking. The surface is oxidized. You've got some transverse thermal cracking, and then some longitudinal joint separation. So this road isn't in bad shape, but it probably needs something more than just a chip seal or a slurry seal, but it's not so far gone that you need to reconstruct it. So the key here is you want to take advantage of the assets that you already have out there, which is the asphalt pavement. The local agency has already paid to have this done one time. Hopefully you can rehabilitate this asphalt street without having to mill or totally reconstruct and haul all this material away, and then come back with the newer, more expensive material. So this is a mid-level treatment that's right in the middle of that pavement deterioration curve, somewhere between 7 and 10 years in its life. You can do these type of treatments without having to totally reconstruct your road, which, as we've seen, is very expensive. These are just the 3 examples in your pavement management system. So asphalt pavements, the the way our asphalt pavements fail around here is from the top down. So the aging of the asphalt occurs rapidly at the surface, right? We've got lots of freeze-thaw cycles here in Colorado. It's a real arid climate. We live in a high desert, actually. So the asphalt really deteriorates from the top down. You'll notice a new asphalt when it's freshly paved is black as night, really smooth looking. After 2 or 3 years, the binder starts wearing off of that aggregate. You can start seeing the individual rocks, and the surface starts to gray a little bit. That's just because our environmental conditions and traffic and snow plows and all that kind of thing starts eating away at the top of that surface. Once that starts happening, then the structure starts to fail a little bit. And this is typical with every road. It's nothing unexpected, but an asphalt is a flexible pavement and it moves around a little bit, and eventually it's going to crack. All asphalt pavements crack. So here's some of the things, surface defects that you'll see on an asphalt pavement: rutting, shoves, bumps, patches and utility cuts, reflective and shrinkage cracks, weathering, as we've spoken about, bleeding. If you have, if there might be too much asphalt in your pavement or it's under heavy traffic, you might see actually the liquid binder get drawn to the surface. And then pavement geometry, that has to do with drainage issues. If a pavement wasn't constructed correctly, it might have some drainage issues that you want to correct. Basically building a crown out in the center of that road so that it drains properly. So heater repaving. This is just one of the treatments that's a mid-level treatment. It's classified as pavement preservation, and it's just something that's a little more heavy duty than a slurry or a chip, but not as far gone down the road as a reconstruct or a mill and overlay. In fact, these methods, and heater repaving specifically, is supposed to directly compete with mill and overlays that you would normally do in your system. So typically a local agency or even a DOT would mill off 2 inches of asphalt. They're getting rid of that top wearing surface, and then bring 2 inches of new asphalt back to pave and make that the new wearing surface. Heater repaving competes with that in that it'll recycle the top inch of that surface and then put a new 1 inch wearing surface on top of that, all with the same machine at the same time. So effectively you're getting a 2 inch overlay, just like you would with a 2 inch mill and overlay. And like I said, it's all done with a single machine at one time. So I'll briefly go through the process of heater repaving. And it's not just Cutler Repaving that does this. There's other companies in the region and across the nation that do hot in place recycling. Cutler is a little bit different, and I'll explain that as we go, but basically the same concept. You're heating, melting, reorienting, rejuvenating the existing surface of asphalt pavement and laying it back down, and then either following that directly with an overlay or as another process with an overlay or a chip seal. So heater repaving is a 6-step process. First step, heat the pavement. These are what our preheaters look like. They're all propane driven. The heating complex is over here. Propane driven flame is blown down into these heating hoods that are riding about 1 inch off of the asphalt surface. So it's not direct heat. There's not flame getting blasted right on top of the asphalt surface. It's indirect heat. There's about 1 inch gap between these hot heating hoods and the surface of the asphalt. The point is, we just want to melt the liquid binder that's in that existing asphalt so we can soften it up and then put it through the recycling process. Here's another version of a preheater. This one happens to be a preheater conveyor vehicle. It's taking asphalt from the front, carrying it all the way over that heating process and to the next step in the train. And we'll look at this a little bit later. You'll understand what's going on as we see it. You can have multiple preheaters. This happens to be a DOT project for Utah. They wanted to recycle a little bit deeper than 1 inch. So to heat gradually, which is the whole key with any hot in place process, you might need to have multiple preheaters out in front so that you're not blasting that existing asphalt surface and destroying the asset that you have out there, which is the asphalt and aggregate that's currently making up your roadway. That's a close-up of it. As you can see, it rides pretty close to the top of the surface, but all that is propane-driven flame blowing down into that heating hood and really making it hot so that we can melt that surface. Second step for our system is to scarify the pavement. So what happens here, you've got a hot, melted existing surface, and it's not a milling head that goes through and grinds all that up. We have carbide tip scarification teeth. So basically steel combs that pull through that material that's heated and softened. We don't want to break any rock. So that's where we try to melt the surface, comb through it with these carbide tip teeth, and gather up all that material that composes the top inch or inch and a half of the existing system. So you can see the heating, right behind the heating hoods that we saw in the earlier step, we have carbide tip teeth that are just pulling through that hot melted system. There's a close-up of it. You can see the teeth right here. Is my cursor showing up on the screen, Katie?
Sorry, I was muted. Yes, it is.
Oh, no worries. I hate pointing at things and then I'm not actually doing anything useful. So yeah, so the teeth are combing through the material. There's another close-up of it. And then we step back a second. So after it combs through that hot melted material, we have a heavy mold board with a counterflow auger. So it gathers all that material that's been heated and scarified and windrows that in the center of the machine. And that's where our third step comes in. An emulsifying, a rejuvenating agent, typically an emulsion, is added to that hot loosened material that's being gathered up in the center of the machine. We typically use an HFMS2P, which is just fancy for a rejuvenating agent. So all we're trying to do is reactivate that liquid binder that's in the existing asphalt pavement. And so while that material is getting gathered up and windrowed in the center of the machine, we've got these application cups that are spinning this liquid rejuvenator onto all that material and remixing it all in the same step. Another close-up of how that looks. And the amount of emulsion that's added to this process is predetermined by doing a mix design, and the speed at which it is applied to the recycled material is tied directly to the forward speed of the machine. So if the machine's going slower, this addition of rejuvenator is happening at a slower rate, faster. So that mold board is gathering up all that material. We already talked about that, and it's windrowed. The heated loosened material that's already been rejuvenated is windrowed in the center of the machine between the drive tires. And it's laid down with a recycling screed. So it goes all the way underneath these machines. The windrow is here. The machine is moving from right to left. You've got a recycling screed. It's basically just a paving screed. So the windrow gets hit by this auger that spreads everything out again, and it's laid back down at the exact same thickness that we recycled to. So if it was an inch that we were recycling, it's laying down an inch of totally recycled material. In this case, the machine is moving left to right. Here's the recycled screed that's laying down that 100% recycled material that went through the whole heat and scarify system. And then the next step, number 5, virgin hot mix is laid over that recycled material. So if you remember one of those earlier pictures, there was a truck at the beginning of the whole train that came from the hot plant. It dumps into a hopper, and all that new material is carried all the way up and over the top of the recycling process and put back down at the end. So we've got recycled material that's getting laid here with the recycled screed. The brand new material from the hot plant, from that tandem dump truck, carried all the way over the top, and it gets laid down right behind the recycling screed with a secondary paving screed. So you're putting virgin material on top of recycled material, all with the same machine. Here's just some different looks at that. recycled screed laying down an inch, paving screed laying down an inch of new material from the hot plant. And when it comes out the back, it's just like any other paving operation. You've got an effective 2-inch overlay. The bottom half is 100% recycled in place, and the top half is 100% virgin from the hot plant. So at this point, it looks just like any other paving operation. If you were standing at the back of this, you would think it was a conventional paving setup, but that's what it looks like coming out the back. You've got 100% engineered, virgin, designed hot mix out the back. So whatever wearing surface the agency or the DOT wants to specify, that's what comes from the very front of the machine and gets laid down all the way at the back, and that will be your new wearing surface. And it's covering up the 100% recycle that you took advantage of with this whole process. And then the sixth step is no different than any other paving operation. You've got typical rollers behind it, a breakdown roller, a pneumatic tire roller, and then a finish roller. And everything operates exactly the same at this point than you would have in a regular paving operation. So here's just a quick video up close of what this process looks like. The new mix is getting dumped into a hopper right at the beginning there, and it's carried up all the way over the top. This is sped up a little bit, but these are the heating hoods that are melting that lane. In the foreground, we paved this section yesterday. And we're paving the closing pass right now, as you'll see. So that new mix from the truck is getting deposited in the repaver hopper right here. And again, that's going to go all the way up and over the top and to the back paving screed. Here's the finishing touches for the rest of the heating. Here are those carbide tip teeth coming through not only the adjacent lane by about a foot, 6 inches to a foot, but also that existing lane. That mold board and counterflow augers gathering up all that material. It gets rejuvenating agent applied, and then it's laid down by this recycle screed. And then right behind that, the new material clear from the front of the train is laid down to get your finished product. So we'll see that whole process again right here, just from a bird's eye view, and you'll be able to understand what's going on. New mix at the front. This unit is just preheating that material. Again, we're trying not to scorch or smoke that existing asphalt pavement surface because we want to reuse all that material. Here's the virgin material from the hot plant coming into the hopper. It's going all the way to the back. There's some more heating. There's a good look at the scarification teeth. The rejuvenator's added in this step. All that recycled material is windrowed beneath the machine, and it's getting laid down right here with the recycled screed, followed by the virgin mix going right down on top of that. This was an Arapahoe County project. It's actually out by, it's in Dove Valley, right near the Denver Broncos training facility. So pretty heavily traveled road. And the county wanted to do this so that they're kind of in and out without too much disruption from traffic. And at the end of the day, as you can see, this was our closing pass, but it looks like a brand new asphalt pavement across the board. But the bottom half of it's recycled in place, very cost effective. And the top half, only the top half, is the new, more expensive material that came from the hot plant. So I'll just briefly hit some of the advantages and benefits of heater repaving. As we discussed, it treats depths 1 inch to 1.5 inches. So in other words, if you've got something that's going to require a more heavy duty treatment, so something that's deeper than 1.5 inches, really, if you've got base failures or something going on underneath your asphalt pavement, it doesn't make sense to do any of these intermediate treatments, because one of my favorite phrases, you're just putting lipstick on a pig at that point. You don't want to do something on top of something that's garbage underneath. So heater repaving, you want to target just something going wrong in that top lift, maybe 2 inches. where you've got oxidation, minor cracking, minor rutting, stuff like that that you want to correct before it really starts to destroy your pavement. So we're looking at something just in the very top lift of the asphalt. It's a hot process. You can add additional, or you can add binder modifier. We talked about that as our rejuvenator. You're adding additional hot mix. So you need new hot mix no matter what you do, but you're only using half as much as a conventional mill and overlay. Increases the structural coefficient. So an engineering term for the strength of your asphalt, because instead of milling off, for example, 2 inches of asphalt, hauling it away and then bringing 2 inches of new asphalt back, this way you're actually increasing your pavement structure by 1 inch. So remember, we're not doing any full width milling at the beginning in most cases. So we're just recycling that top inch and a half and then adding a new inch or inch and a half. So you're actually increasing your pavement structure thickness and therefore increasing that structural coefficient. Then superior longitudinal joints. We'll talk about that here in a second, but since it's a hot process and you saw in the video that we were recycling and paving right next to a paving pass that we had done previously, we overlap that 6 to 12 inches so that we can have hot material on both sides of that longitudinal joint, and then it's compacted all at the same time. So really, I'm not bragging here, but when you have a hot process and you have a hot joint that you compact, there is nothing better that you can do for a longitudinal joint other than echelon paving. If you had 2 pavers side by side going down the road, you would get a similar joint. But if you think about it, in most cases, if you're paving next to a pavement that you've already done, you're putting hot material next to cold material. And no matter what you do to roll that material or construct that joint, those materials are never going to intermingle. And you can still get good longitudinal joints, but none the quality of a hot joint that you get with a hot process like you do with heater repaving. Some more benefits. We talked about the different things that you can attack with this process. You extend your pavement life, right? So that pavement deterioration curve that we looked at, if you can get into the first 75% of its lifespan and then do an intermediate treatment, you can bump that quality level up to like a brand new condition. And then you might have to wait another 7 or 8 years and you can do another preventive maintenance treatment. You could just keep bumping that pavement quality higher and higher as you go down the road, instead of waiting for it to get to total failure and then do something real expensive to get that back up to a like new condition. So again, that's just the part of the pavement preservation concept. Improves ride quality, so smoothness. So if I could go back to my days at the Colorado DOT and these types of processes were out there that I went and looked at, the 2 things that stuck out for me were that longitudinal joint quality and smoothness. So as you saw, the machine, the train is a big, long thing. It's about 55 feet long. It's rolling down the road. The toe point on those screeds is so much longer than a regular paver that it generates a really good ride quality. So the smoothness is greatly improved when you're doing this type of process. Along with that longitudinal joint, you get really good ride quality. Those were the 2 things I've always been impressed with, even before I came over here to the dark side. So a lot of places have even put a smoothness spec, a ride quality spec on heater repaving projects. And I think they've realized that that's a good thing, that this process can indeed give a very smooth riding pavement. In addition to that longitudinal joint quality, because that's, other than the surface across the board, a longitudinal joint is the first place that an asphalt pavement will start failing, because that's where all the incompressibles and the water gets in there and freeze thaw cycle. That's the first place, in addition to the surface, that starts to fail. Another benefit, improves friction coefficient. That's because we're overlaying with the material that the agency or the DOT wants to use as their wearing surface, so they can specify whatever they want. conventional HMA, warm mix, SMA, any type of hot plant produced material that the city or the county or the state wants to use. That's what we'll put through the machine, and that will become the eventual wearing surface. Improves appearance and bonding. Yeah, like we talked about, every new asphalt pavement is nice and black and smooth, and it's just pleasing to the motorists. And with heater repaving, you can do all that in a single pass with a single train and within a single lane closure. And we'll see a video here later of what that looks like. But instead, as opposed to milling one day on your project and then coming back to pave, you kind of get all those things done in one fell swoop. Two birds with one stone. You're getting basically the mill and overlay accomplished all with the same machine. And that's always pretty cool because nobody likes getting phone calls about, hey, why am I late to work because I've been waiting in traffic 2 different days for this paving operation to go by. So some of the specifics about why a local agency or a DOT might select this. It's a mid-level treatment, whatever index system you want to use. Between 60 and 75. That's like a C minus to a B if you were to grade your roads. It's not quite to a D or an F. Those are the ones you're going to have to totally rebuild. It's not an A or a B plus, something that you can get away with doing a chip seal or a slurry. This is one of those that's it's passing, but it's doomed to fail at some point. So you're looking for these defects: thin lamination, minor block cracking. You might want to clean up some utility patches. You could have some potholing. You don't want any major structural defects. So when I go out to look at potential candidates, if I see that there's alligatoring or severe, pavement stress going on, you don't want that. Really deep raveled cracks that go all the way down to the base course, you want to stay away from that. Anything that shows major fatigue failures, and that just means that your pavement isn't good underneath, so it's not going to matter what you do on top. It's not going to last very long no matter what. It's a good mid-level treatment. It's environmentally sustainable, which a lot of people are really concerned about that these days. You trying to use fewer and fewer raw materials. So if you can do something that gives you the same pavement structure as one of these older methods, like we talked about, mill and overlay, you're milling off 2 inches and hauling it away. You're going to have to replace that with something, which invariably means 2 inches of new material that's been quarried or mined, processed, put through a hot plant, and brought back to you. If you can use less material and get the same finished product, that's where this environmentally sustainable process comes through. So you're using less raw material. Obviously, if you're only using half as much new material, the rest is recycled in place. That's a good thing. And to be honest with you, I put my pavement and materials engineer hat on again. There's no need to waste that existing pavement. Yes, it's failed, but the rock isn't the problem. It was good when it was paved. It's been good for millions and millions of years. It's a shame to take that material and waste it because it's still in good shape. We're just trying to rejuvenate that binder that's holding that existing material together, reorient it a little bit, lay it back down, and it should be good from a structural materials point of view. It's not just a sales guy talking, but it gets the equivalent life of a 2-inch mill and overlay. In fact, the CDOT manual gives it the same structural value as a virgin 2-inch lift. A one inch plus 1 inch repaving lift gets the same structural number. We talked about using whatever mix you want to put through as your wearing surface through the machine. That's another benefit. And then this one's a little conservative, savings of 6 to 10% over a traditional mill and overlay. It's probably a lot higher than that, but we don't want to infuriate anybody within the industry, but it makes sense. You're only using half as much of the new, probably more expensive material. If you can recycle something in place, it's a lot cheaper, especially when you consider trucking, lane closure costs, all that sort of thing. Additional funding through IIJA, that's just the federal means in which local agencies and DOTs get money to do these projects. It actually talks about if you're doing a pavement preservation treatment, like a chip seal or cold in place recycling or hot in place recycling, you can get money that you normally wouldn't get if you were doing a conventional mill and overlay or a reconstruct. So what that federal funding mechanism did was actually open the window for local agencies and DOTs to raise their hand and say, hey, I'm trying to keep a good road good. It's more cost effective in the long run. And now the federal government will actually siphon money down to local agency level or DOT level if you're doing these type of treatments. And then this is kind of the newest hot concept, EPDs, environmental product declarations. So we live in a state here in Colorado that's one of only a couple that's got legislation on the books where the paving industry has to provide environmental product declarations for steel, concrete, and asphalt. So if the DOT is doing a project that involves an HMA overlay, the supplier producer has to generate a document called an environmental product declaration that quantifies what kind of carbon footprint they are creating by producing that asphalt. And that comes down to greenhouse gas emissions. So however much greenhouse gas your product, takes to produce, in other words, the environmental effect that asphalt has on the environment. You have to generate a document that actually quantifies that. So again, just I guess a side benefit of doing something in place where you're recycling, you're not having to go through near as much heartache or environmental score as if you're using raw virgin material that actually has a higher effect on the environment than recycling in place. But that's a whole nother can of worms that maybe Katie will find an expert to come talk to you guys about later on. So these are just some of the local agencies that have done heater repaving projects in the past. Some of you that are watching this in the future might be in these spots, but Denver is kind of one of the biggest users of heater repaving. They generally do about 100 lane miles per season of this type of process. And it's mainly because they have plenty of streets, their funding streams are healthy, but they don't have enough resources to actually do the work. So they will specify about 100 lane miles every year that gets a heater repaving treatment. And then that way they can focus on some of their other issues, whether it's a chip seal program or the other end of the spectrum where they need to do a little something more substantial like a mill and overlay or a total reconstruct. Past users, Boulder, Arapahoe counties, Silverthorne, and Summit County area. Grand County had a good project we'll talk about in a minute. And then more along the Front Range, Loveland, Westminster, Thornton, and Centennial are regular users of heater repaving. So Denver, these numbers are pretty old. Millions and millions of square yards for the city of Denver. It won a 2014 CAPA award. Then I just threw some pictures of what our finished product looks like in those areas. Boulder County did a fairly substantial project in 2017, and it won what they're calling their Pinnacle Award. So this was before that whole EPD environmental situation came up. The folks in Boulder and in Boulder County actually award projects internally if they were environmentally sustainable and something that was good for the environment, good for your surroundings. This was way out on the Weld County, Boulder County line at the end of the project. Arapahoe County, we talked about that down by Broncos training facility. It was a good sized project. And this one, they actually incorporated CDOT smoothness spec as we spoke about earlier. So a local agency utilized the DOT ride spec on this project because they didn't just want to listen to the sales guy or whatever. They wanted us to actually put our money where our mouth is and produce a smooth riding pavement. And it maxed out every force account item for the CDOT smoothness spec. So it met a state highway ride requirement, even though it was just a county project. There's the training facility in the background. This might have been the last time the Broncos were doing well. And I'm a Broncos season ticket holder, so I'm allowed to blast them when necessary. But those were the days, and that was only back in 2017. Loveland, it's been 10 years running that they do projects on a yearly basis, generally 1,000 square yards or 100,000 square yards each year. It's just part of their system. It's one of the tools in their toolbox that they use every year to go along with their other treatments. Westminster has done 3 different projects. It's won awards in the past. I believe this was 128th Avenue. I was just trying to get the mountains and the blue sky in the background. Given today it's snowing and dreary outside, I might leave this one up there for a little bit longer. Thornton has become a big user of heater repaving, a number of Kappa projects of the year. And again, they're generally around 100,000 square yards, but it's become one of their go-tos. They do a lot of in-house mill and overlay projects, and they were able to set aside funding to do this type of treatment on their roads that are still in fairly good shape. And eventually they'll get to a point where their good roads are still good and they can attack some of their other problems, all within the same budget. Centennial, again, one of the forerunners in this carbon footprint issue and the greenhouse gas emissions. They actually started monitoring this clear back in 2013 when we did our first project for them. So they're calculating trucking, milling, how long people are waiting in the queue to get around projects, that sort of thing. So they had the foresight to look into, hey, these processes, how do they compare to other processes? So a few projects of the year, APWA actually nominated for an award. It's out obviously on the eastern part of Centennial. And then up in the mountains, local agencies, a county and a town in this case, collaborated to, I think one of them provided trucking and the other one had an asphalt supply contract. And they had Cutler Repaving come up and do some work. So again, they're just trying to get the most bang for their buck. And if both agencies can combine to do a project and help maintain, preserve, and rehabilitate their system, they thought they came out on the winning end of that. Copper Mountain, I'm sure a lot of you ski heads have driven on this road to get up to Copper Mountain. So that's what it looks like in the summertime. And then Grand County, this was actually my first year of working for Cutler, way up on top of Ute Pass, if anybody knows where that is. It's an old asphalt road that serviced a molybdenum mine back in the day. And the county took over maintenance of it and had us come up there to do some work. But the thing I liked, it was the highest road in Cutler Repaving's history. So I have a claim to fame about something anyway. That's what that guy looked like. It's always good to go on a field trip to projects like this. And then Littleton, this is going to be a new project this year. And I think Katie's going to provide some contact information, and I'm going to kind of make a big deal about this project that's upcoming. We're going to be starting that here in a couple months for the city of Littleton. They're doing a project on County Line Road between Santa Fe and Broadway. And I thought it was important because they're doing something a little bit different than most of our customers do. And again, this is they're evaluating their own road and trying to come up with different ways to attack the problems that are going on out there. So they're going to have us mill off 1.5 inches all the way across the roadway, and then come back and do our heater repaving process, recycle the inch that's down under that mill, put 1.5 inches wearing surface on top. So a heater repaving 1 plus 1.5. And then they're going to have us apply that SMA as a wearing course. So we're going to put SMA through the train, and lay that down as a wearing surface. So a little bit different combination of geometry and process and wearing surface as part of the heater repaving process. So a little bit different. And we're going to have, in conjunction with Kappa, maybe even LTAP, but the Littleton themselves wanted to make a big deal of this and probably have a number of open houses as this is under construction. And I'd invite everybody to come out and take a look at it. It beats a sales guy talking on a Zoom presentation about this process when you can go out there and watch these machines running down the road and just get an idea for what they do and what you can accomplish. So you'll probably see some more information about this. I know Kappa is going to advertise it, and we'll try to make not a big spectacle, but a big opportunity for everybody to gather around and see what this is all about. So again, this is that Broncos Parkway project, but that's what it looks like from the top. You can see, yeah, we had to close another lane as we're right next to live traffic, but really you're doing nothing more than a mill and overlay would have accomplished. The train's a little bit longer, a little bit more excitement around it, but at the end of the day, you're getting a brand new asphalt pavement, at least an asphalt wearing surface for the same thickness of pavement that you would normally. So there's a good shot of the delivery truck out in front, dumping into the machine, and all that new material is going all the way to the back and rolled out just like a regular paving project would. Cool. Well, I'm sure you're tired of hearing my voice ramble on and on. So I don't know if there's anybody on board. I didn't see any chats pop up, but if you got any questions, hopefully I've got some answers. And if you're too shy to raise your hand, I'm sure you can get a hold of me at some point. But it was a pleasure joining you folks and helping to contribute to these workshop Wednesdays.
Awesome. Thanks, Todd. It looks like we actually did have a couple of questions in the chat. Would you want me to read them off to you? Or?
Yeah, absolutely.
Yeah. So the first one asks, what is the maximum width that it can go?
Okay, so our machines in particular are set up to do anywhere between 11 and 17 feet wide. And some of our trains have an extendable hydraulic screed on the back. So we've actually come up with some different combinations where we can recycle at one width and then put that overlay down at a different width. And that comes in not so much local agencies, but out on these state highways where they want to improve their shoulder. So we can actually pave wider than recycling, but minimum of 11 feet, and then any combination you might have out to 17 feet.
Awesome. And then the second question says, if you know that the asphalt that was installed was faulty, would this process be beneficial?
Yeah, I think anywhere, if it's in that top lift, so like the last paving operation that went through there 12 or 15 years ago, if you know that your defects are mostly contained to that top lift, in other words, minor rutting, oxidation, minimal thermal transverse cracking, that sort of thing. As long as you know it's confined in that top lift, absolutely, this is the process that you can use to attack that. Anything that's deeper, heavy fatigue cracking, alligatoring, base failure, subgrade failure, that sort of thing, that's deeper. You need something different. So if it's in the surface, any of the in-place recycling treatments are a good option.
Awesome. All right. Well, I think that is all for questions. Yeah, anything else?
That's about it. Again, it's my pleasure. Thanks for inviting me to chat with everybody. It's not a day to be playing golf anyway, so this this worked out great.
Absolutely. Yeah, well, big thank you to Todd, and big thank you from Cutler Repaving for presenting today. As usual, this will be uploaded to our YouTube with all of Todd's contact information. Yeah, big thank you. Thank you so much.
Oh, no problem. Have a great day, everybody.
Thanks, you too.